Hello everyone. How are you all feeling? Are you wide awake after lunch or just hoping for a nice sleep? Okay. So welcome to this session. I think I'm supposed to say the full title, so I'll take a deep breath because it's a nice short one. Deploying a business critical application with mixed ARM x86 CPUs in Red Hat OpenShift. It's a really good session. My name is Duncan Hardie. I'm part of the OpenShift product management team. I am so lucky today to be joined by Farhat, who is from Microsoft, and we've got Antoine from Amadeus, which hopefully you saw the keynote early on. I got a kind of pre-taster for it. We're going to talk to you today about the great things that Microsoft are doing with ARM and Azure. I'm going to tell you about a new technology that we've just GA'd as for part of 4.13 called multi-arc compute, and then what you're really here for and what we're really here for as well is to hear Antoine tell you all about what he as a customer has done with that and how we all worked together over the last year and a half to kind of bring this through into something that will hopefully soon be going into production. So with that, we're going to start at the bottom of the stack. I used to say the most important part until I moved into Red Hat, of course. So I'm going to hand over to Mo, and he's going to chat to you about what he's up to with ARM and Azure.
Thank you, Duncan. Hello, everybody. Is this working? I think so. And thanks for the love for the infra people. My name is Farhat. I lead product management for ARM-based VMs in Azure. And I'm excited to talk to you today about our ARM-based VMs, what their values are, and then leave the maximum amount of time for Antoine to go through what they're doing there at Amadeus. Let's get this going. All right, so I'll start with an overview of Azure's virtual machine offerings. Azure provides a broad range of virtual machines, as you can see, to fit the workloads that run your business, starting from A-series virtual machines that get you started with test and development environments at a low price entry, burstable virtual machines that give you performance when you need it, and lower your costs when you don't. And of course, our mainstream D, E, and F, general purpose, memory optimized, compute intensive, and confidential computing VMs. They'll run most any workload. And our specialized VM families, our L series storage optimized machines, our N series GPU accelerated machines for AI, visualization workloads, and of course the H series machines that will handle the most demanding high-performance computing applications. So I want to zero in here on the DPS, DPLS, and EPS series that you see up there, a little bit more detail, starting with the DPLS series with 2 gigabytes per vCPU and sizes up to 64 vCPUs, the DPS series with 4 gigabytes of memory per vCPU and sizes up to 64 vCPUs and 208 gigs of RAM, excuse me, and our EPS series with 8 gigabytes of memory per vCPU up to 32 vCPUs. Now these machines are excellent for web application servers, microservices, open source databases, data analytics engines, and more. So let's dig in a little bit here into the value of ARM. ARM is really blooming in the data center today, and it's because it's providing that excellent price performance in the workloads that we mentioned there. And the performance characteristics of the machine are in providing consistent performance. So these machines run on the Ampere Ultra processor, running at a consistent 3 gigahertz, and it does so power efficiently to help you reduce the carbon footprint of your operations as it does that. And of course, these machines are priced up to 20% lower than equivalent general purpose VM sizes. This is a general value proposition here. If you can jump into the performance characteristics, an important point in that ARM machines provide a full physical core per vCPU. And what this results in, particularly for scale-out workloads, is a linear performance scaling with thread count. As thread count increases, up to the vCPU count of the size of the machine. And it also, providing a physical core that is, reduces the tail latencies associated with thread switching in simultaneous multi-threaded core designs. And this reduces that tail latency that defines, in many cases, the end user perceived performance of the scale-out workload. So scale-out workloads love full physical cores. Of course, these machines are available for you to access, deploy, manage, just like any other virtual machines in Azure. So they're available for use in the Azure Resource Manager, Portal, or CLIs, SDKs, PowerShell, with full suite of management functionality, including VM scale sets, and integration in Azure more broadly. They're fully supported in the Azure Kubernetes service, Azure Monitor, Backup, Defender, and more. It's important for us that you have a seamless experience with these machines, just like you're used to today. And with that overview, I'll hand it back over to Duncan to talk about the heterogeneous architecture, and I'll be happy to answer some questions towards the end.
Okay, so let's talk about multi-architecture. So I'm not going to insult you by saying who's heard of ARM, but who's got an ARM system at home now? Got some hands up? Yeah, excellent. Okay, good. So why multi-architecture? So I'm going to start by undermining myself. OpenShift already supports multiple architectures. So we've got support for Power, we've got support for Z systems, we brought support on for ARM in the 4.10 release. But what I want to talk about today and what Amadeus are doing and Antoine will talk about is actually mixing these architectures within a single cluster. So up until now, up until we GA'd a few days ago, you had to run your OpenShift cluster had to be all the same architecture. And we're looking at it, why now? So a lot of people put their hands up in the audience. We know all the big cloud providers. Mo's already talked about what Microsoft are doing there. They have ARM in their environments. Customers want to use it. We're seeing it. We've actually seen a growing adoption trend on the IBM Z system and Power systems as well. Where we see the major opportunities for this, you probably know this better than I, is out there in the cloud itself, right? If you want to pop up an ARM instance, Microsoft and Azure have made that really easy to do. Go ahead and try it. But we didn't want to just jump into this. We knew there were some questions to answer. What are the main use cases? Why do you want to do this thing? Multi-architecture sounds cool, but what do you want to play with it for? What are the actual benefits of doing that? Are there different ways that were already available that could solve the same problem that you wanted to go after? And then finally, is this something that the industry really wants to do? Is it a trend that we're seeing? So we did our homework. I know sometimes you look at product management and you think we don't have a clue what we're doing. We just randomly throw things out. No, we like to know what we're doing and give you something we want. So we see three main use cases. There's a lot more around here, but these are the ones that we saw. The first one that we talk about is changing architectures, right? So this is the main driver for the technology I'm going to talk about a lot today. Customers are seeing what ARM's doing. They're going to talk to Mo and say, yeah, I would very much like to save 20%, possible 20%, right? So they want to change their architectures, but I don't know about you, but in my bitter youth, and yes, I've been around for a long time, when I used to see projects that kind of do a big bang approach, a big jump over, I was always really worried about it. The projects that did the baby steps, that tried things out first, those were the ones that tended to be much more successful, right? Because they knew where you went wrong. So we wanted to enable that. Let's bring in, you want a different ARM system in your x86 environment, let's bring that in. There's also legacy applications, so to misquote Beauty and the Beast and show my age, this is a tale as old as time, right? VMware and vSphere came on the back of legacy applications that customers have. Maybe you don't have the code anymore, maybe the person that maintained it's left, maybe it's just something, an application or a service that is so big at the moment that you don't want to handle that thing, you just want to keep it around, but you want the rest of your environment to be another architecture. So that's kind of one option that you can use to keep it around. And then the last one, these first two are much more what I would say focused on the end user. The last one's more towards the cloud provider. And this is the idea of, I've put it in quotes, lower cost control plane. So again, if you're a cloud provider or internally doing a cloud service, maybe it is x86 you want to run on, or let me throw Z systems into the mix, right? Maybe you want to run your workloads on there, but for the control plane on OpenShift, you want to run on a 20% saving architecture, so we'll help you to do that. So we came up with two technologies to kind of go after this. I think maybe skipped a slide, okay, maybe not. The one that I particularly own is what we're calling multi-architecture compute. As I said, it G8, and it does exactly what it says on the tin. So you start off day one with your standard OpenShift cluster as normal. So here we're running x86, and then as a day two operation, you can start pulling in ARM nodes and adding them in. And then you just go ahead and schedule your workloads on the cluster itself. What do we support as of GA? So obviously Azure is there. There's also AWS. If you haven't heard of that, talk to Mo. I'm sure he'll explain what it is. And we've got a tech preview for bare metal for those of you that actually managed to get some ARM servers in your environment. There's a couple of ways to get running. If you're doing greenfield, you just install OpenShift as usual. You use our multi-payload, and you're good to go. And you can add those nodes in as day two operations. We're going to have, this is the first release, but going onwards, we'll have upgrades. So everything that's good about OpenShift upgrades, and I hope you're all nodding about that, will apply here. We'll take you seamlessly there. If you've got a brownfield environment, where you will need to do a switch over to our multi-payload, it's kind of like a minimal upgrade. We'll go and redo the operators, but again, all supported. And we've done things under the covers. So one of the early issues we had was OC debug. So we had something called an internal registry. You run OC debug on the ARM node, it goes and pulls down an x86 binary, of course, which doesn't work. So we had to do some work there to figure that out. So that all works nice and cleanly now. So we are giving you a pair of sharp scissors and asking you not to run with them at the moment. And what I mean by that is there are some bigger picture things that you need to think about if you want to go down this multi-architecture strategy. So your application itself and the operator, does it run on the architecture that you're choosing as your second architecture? So let's assume that's ARM here. Do you need something like sparse manifest support? So if you look at our multi-payload right now, that has everything in it. So it has everything for x86, everything for Z system, everything for power, everything for ARM. It's quite big. So you might want to look at, and certainly something we're doing, looking at the idea of these sparse manifest lists. How are you going to build what you're going to run in your environment? What does your CI/CD look like? Again, do you have to test everything everywhere? Is it enough that there's a common stack that you can test on one architecture and then there's specific things that you go hunt? Do you want your applications to be able to run on all the architectures that you have in your environment? So are you going to be building fat binaries, or are you going to use things like taints and limits to kind of make sure that the right architecture runs in the right place? But enough product. Actually, I will mention one more thing. I think the slide's kind of gone missing on that. There is something called hosted control planes. Has anyone kind of heard about that? Any hands? Okay, this is a technology that we have that essentially, to understate what it does, the team have containerized the control plane. So you can run your control plane as a pod. Now, this one is aimed at, remember the diagram I said of the use cases at the start? This is the lower cost control plane option one. And what you can do with that is, because you've containerized your environment, there's some specifically designed things that you can take advantage of. So the first one is you can do consolidation. So you can have your control planes just a pod, you can have multiple control planes on a single system instead of having to have 3 per cluster. So instant savings there on top of your 20%. There's also an interesting security model that if I had the slide, I'd show you, where you've got separation between church and state. And what I mean between that is between the control plane and the actual compute nodes themselves. So you can do some interesting things. So your developers have absolutely no view into the control plane, and you can fence that off. And the other one that I really like is, again, in the cloud world, is these are pods, right? So once you get the first one built and up and running, you can get multiple control planes up very quickly indeed. And the reason why I also mention it in this talk is that multi-architecture bit. So you can have your control plane of ARM, and you can have your compute nodes as some other architecture. But You weren't really here to listen to me and Mo do product pitches, right? Which you all love. You want to hear what real customers are doing with this stuff today, and I will kind of spoil Antoine's talk a little bit, in that they have worked together. You know, what has been good about this project is all of us working together on it. So, Antoine, tell us what you're actually doing with this. Well, I'm going to say cool technology. You're probably all nodding off now, but I love it a bit.
Indeed, Duncan. So let's talk about our use case. Before a little presentation of my company, Amadeus. So a little question here: how many people in the room know Amadeus? Okay, quite a few. Still a little presentation. So you probably already used some of our software and services to search for flight, to book an hostel, to book a cab. So we are here at every step of the traveler's journey. Really, our goal is to help our customers, the industry, to power better journeys thanks to travel technology. So a few figures. So we are more than 18,000 employees worldwide. Last year, more than 1.5 billion people were boarded in planes thanks to Amadeus and Ritter solutions. And we have a large software footprint, for instance, in our main data center last year. So we processed peak time more than 100,000 user transactions per second. So now, a little bit of context. So back in 2021, Microsoft and Amadeus signed a strategic partnership. So with the idea of fostering innovation between our companies, collaborate across the industry, and to accelerate our migration to the cloud. And so for us, we are executing since then a massive migration and transformation program. It's not only a migration, for us it's also an opportunity to transform our application. So for instance, generalize OpenShift as the container orchestration layer, introduce new technologies and services, for instance, Azure Databricks, and to explore new hardware opportunities, so high-performance computing, FPGAs, GPUs, and ARM. So knowing that Mo was introducing in Azure some ARM servers, the question we asked ourselves is, would those new Azure ARM Aper servers be beneficial for some of our backends? So I'm going to tell you a bit about the journey we had, so together with those two gentlemen and within our three companies. So three main questions we want to answer. Is this a good idea? How to industrialize it? And can it work at scale? So for the first question, is this a good idea? Let's make a little detour by CPU architectures. So I guess most of you are familiar with it, just in case. So you have a really simplified computer with an application and operating system. So when you want to run on a CPU and to instruct the CPU to do some useful work, the program has to talk to the CPU in a machine language specified by an ISA, so an instruction set architecture. So that's true for most languages, whether compiled or interpreted. So at some point, it is translated back inside the machine instruction. And here we have an important fact. The ISA of ARM CPU is not the same than x86 that is used on Intel or AMD CPU. So if you take your application that is today running on an Intel CPU and you bring it to an ARM server, it won't work. You need to recompile your application so that they can run on an ARM server. So that means a bit of effort. So I guess you're wondering what would be the benefits of doing those efforts. So there are four main points we can discuss. The first one would be potential performance improvements, so on latency and our throughput. Second one would be run cost reduction, and also as introduced by Mo, a better power efficiency for those CPUs. Additional option inside your portfolio of machines. So for instance, capacity-wise, you have a new type of instance you can deploy for on-demand or spot instances. Vulnerability-wise, because it is a different architecture. And also capability-wise, in case there are a few features you're interested in that are specific to this architecture. And last but not least, it's also an opportunity to update your software and infrastructure. So ARM servers are quite recent in the IT world. And so if you want to benefit from them, you have to update your infrastructure. So it's an opportunity to reduce technical debt. So here we'll be mostly focusing on the two first items that we'll factorize inside a single metric that we'll call a performance price ratio. And thanks to that, we will be able to compare the different virtual machines. So we know that it can be interesting to migrate to ARM. Now the question is which application to migrate to ARM. So here is a little list of the potential ID of an application to consider for a migration. So the first point would be, as we just said, something with a recent version of software dependencies and infrastructure, so that you minimize the migration technical debt. Something with a simple bit system, few software dependencies, a limited number of teams involved, so as to minimize the migration complexity. Quite possibly something coming from an interpreted or just-in-time compiled language, so Python, Java. So if you have a containerized workload, you just have to change the base image so that it is easy to port to ARM. No custom assembly machine language in code. So in the industry, not much people are doing that, but if you are doing, it can be more effort to port to ARM. Multi-threaded workload to leverage the higher core count of Peratra server for better performance. And an application using significant capacity so that you have a return on investment on your migration efforts and costs. So in Amadeus, we looked at several applications that we could consider for this migration. And one we consider was the shopping backends. So they are used when you search for flights. So that's after the inspiration step, so for which budget, where to go in the world, and before booking, so actually buying your flights. So when you have this kind of request, for instance, going from Nice to Boston during these dates, you have potentially a shopping request that is sent back to our backends that will be processed in something we call the shopping engine. And the responsibility of this shopping engine will be to answer back to the client with the possibly cheapest flight, the fastest flight, possibly the flight with the most services for a business traveler. So it's an online transactional application. It is quite CPU and data intensive. So lots of data are necessary to explore the potential flights. So all the possible flight combination between the airports, how many seats are remaining for a given class in an airplane, and then all the potential taxis and fares you need to compute to try in infinite time to give back answers to the client. It's written in a C++, in a complex software stack. We have a mono-threaded multiprocess paradigm approach, and it's based on an in-house compilation to shell with a several bit system. So now maybe you are wondering, that's not what we said on the previous slide, so that's not the typical candidate to consider for my ARM migration. But still we went for it for two reasons. First one is it uses lots of server capacity. So any benefit you can get from this server CPU architecture can be at scale interesting. And also, since it's quite complex, if we manage to succeed the migration for this product, we can be rest assured that we can do it for any product in our company. So now we know we want to try an ARM migration. We have a candidate application, and now what's the next step? Benchmark. So there are two complementary benchmark approaches. On the left side, industry synthetic benchmark. So it can be really interesting if you want to have a peek at a given performance metric for network, memory, CPU. And applicative benchmarks. So each application has unique CPU and memory usage patterns. So it's interesting to test your own application to see what it gives in terms of performance. Doing so, you can also assess your own application's technical and functional KPIs. So that's interesting when you're trying to migrate to a new server architecture. And also, when you have a complex software stack and toolchain like us, it helps validate the portability of everything. So that's what we want to do. So we want to run a benchmark for our shopping backend. As we said, we have specific challenges for our application. So complex software, numerous dependencies to recompile and then validate, further runtime dependencies to have something running in production-like conditions. And actually, we need production-like conditions because our application is way much data-driven. So if you want a meaningful performance result, you cannot do it on your laptop. You need, ideally, the full application in production-like conditions. But we don't want to do a full migration effort upfront. So what we did was to isolate the core code of our shopping engine, to cut most of my middleware dependencies, to have something that is easier to port to ARM. And we captured all the data for the collateral calls so that we have a benchmark that is portable and also, most importantly for benchmark, repeatable. Thanks to that, we have something we can run from VM to VM to compare the different performances and have some kind of performance price ratio comparison. So the way it works is that we have a fixed set of shopping requests, and we put a given number of backends that will process those requests. And then we do it again with more backends until we exhaust the virtual machine. We have a VM load approaching the 100%. And doing so, we can see the evolution of two main KPIs, for instance, response time of our application and throughput. And so what we get is this kind of graphs. So the gray is not displaying, but I guess it's fine. So on the top graph, you have on the y-axis 90th percentile response time of our benchmark application. x-axis, the normalized query per second per number of vCPU. And on the lower graph, it's the VM CPU load on the x-axis. So the first interesting point to look at, in purple, we have the Ampere Altra ARM server on Azure. There is no simultaneous multi-threading, no hyper-threading for those ARM machines. So one vCPU that you rent on Azure for those machines is one full core. And so you get, when you normalize per vCPU, better performance. You can see that it scales linearly. You don't have something that, like on SMT general purpose machines, goes into a shape like that. Also a good core performance for this application. So you can see in a normalized QPS that you have more throughput on those machines compared to other Intel or AMD VMs. And also an interesting vCPU pricing. So we can combine everything inside this little chart. So you have on the y-axis the average response time. So it's percentile compared to the reference that is Intel Ice Lake. So in terms of response time, for our mono-thread application, we can see that it's on par with the previous generations from Intel and AMD. Though in terms of performance price ratio, we can see that it's far ahead of other instances, because when you combine all the aspects we mentioned just before, it gives a really interesting performance price ratio. So we wanted to answer the question, is this a good idea? So looking at that, we find, okay, we can consider maybe for this shopping application or other applications, and typically for an application that is throughput oriented, you can really have a look at those instances. So for us, that was a go for the next step, which is industrialization. So now, you would like to migrate your application on ARM. The next step is how to industrialize it. So basically, how to deliver code and containers for ARM to be able to iterate and to consider production. Most of you, I guess, have a CDP, so continuous delivery pipeline, based on x86 in your company. And so if you want to add the capability to deliver for ARM, there are three main options. First one would be native compilation. So basically, you plug ARM servers inside your CDP. So in the pros, it's natively fast. It works for both code and containers. In the cons, you need a new infrastructure that can be a bit maybe troublesome if you are on-premise, that you need to plug inside your CDP. And also, you need maybe to handle some distributed build pattern, so to send the build on the ARM nodes, reconcile artifacts, and make sure that all the versions are aligned. If you are already, for instance, on Azure, maybe it's easier to have your CDP connected with the ARM servers. Second option is a cross-compilation. So basically, you use a toolchain that is able to deliver code for the ARM architecture. So that's natively fast. So like you would have a native compilation. No need to buy extra infrastructure to plug inside your CDP. But it only works for applicative code. You cannot cross-compile containers. So it can be paired with a third option, which is emulation. So you can use tools like QEMU and bin format, basically to translate ARM CPU instructions that will be able then to run on the x86 machines. So it's really easy to set up, practical, no need to buy extra infrastructure or to set up extra infrastructure. Though it's not magical, you have a build elapse penalty because you need to emulate this architecture. And typically, you will get a factor of 2 to 25 in terms of build and runtime compared to native. So that's the three main options, but fortunately, thanks to the open source community, there are tools that help to lessen the burden of handling those multi-arch capabilities. So for instance, multi-architecture container images with tools like Docker, Podman, and Linux. So for us in Amadeus, we are doing a mix of the three strategies. So notably, we are still running most of our CDP pipelines on-premise. So we bought 2 Ampere Altra servers. So later on this year, we want to plug some Azure ARM servers inside our CDP. And we use Jenkins, and you have here 2 examples of pipelines. So on the left, a build that is distributed both on x86 node and on ARM node. And on the right, a multi-arch container that is built with Docker buildings thanks to QEMU and bin format. So little warning. So depending on how you do it, introducing a new CPU architecture in the mix can increase your storage artifacts and the CDP costs. So possible mitigation, probably you don't want to have every Git push that is recompiled and tested for ARM, especially if you have in your company people that are used to iterate on pull requests before having them ready to merge. So if you were trying to build and test for everything, you would need to possibly double your infrastructure. And from our experience, it's a bit overkill because ARM server architecture is quite mature. So you have little chance to introduce bugs that are ARM specific. So probably without disturbing too much your developer workflow, you can test only at a pull request merge or release time. So we tackled the generally in the industrialization part, and now the next step. So we are able to iterate and to deliver code into production. So how to actually have the application running in production. So in Amadeus, we use OpenShift extensively. And so in terms of requirements, what we want is to avoid, like Duncan said, a big bang migration, because we know it's not the way to handle projects easily. We want to have a minimal number of applications and teams impacted by this migration. We want to avoid doubling the number of OpenShift platforms, to have ARM-specific platforms, Intel-specific platforms, having to support the two of them, with possibly the ARM platforms being a bit like the lesser parent that is less focused. We want also a seamless migration of existing cluster, and we want seamless operation via node concepts, so machine set, label, taints, etc. And the solution for that, it has been introduced by Duncan. It's the multi-CPU architecture heterogeneous OpenShift. So OpenShift, thanks to that, we can see that OpenShift really abstracts away any infrastructure concerns. And for us, we enable ARM production without to have a full re-architecture for a company, without having a full recompilation. So that's, for instance, here, a completely false architecture diagram, but just for the ID. In the same Azure virtual network, you can have your database that is here, Couchbase, running on the IaaS, your OpenShift cluster that is deployed alongside it. You have Intel machine sets, and you are able in day 2 operations to add the ARM machine set on which you deploy your ARM application. Everything is living at the same space, at the same place. You can have interactions between all the services. And thanks to multi-CPU architecture, you have hundreds of teams and applications that are not impacted by this migration. So maybe looking at that, some of you are wondering how does it work, and Duncan spoiled a bit. So basically it runs with existing Kubernetes and OpenShift concepts. So here you have an x86 worker node. You have the label for the architecture that is populated on the node. And you have an application with a x86 or AMD64 image that is deployed on it. So in day 2 operation, possibly you add in your cluster ARM nodes. And you don't want to have any x86 application that is scheduled on those ARM nodes. You want to segregate, let's say, those ARM nodes, because as we discussed at the beginning, if you boot an x86 application on this ARM server, it won't work. So thanks to taints, you can make sure that your existing application will not be scheduled on those nodes. And you can decide to have, for instance, an application B that has the corresponding toleration that allows it to boot on those nodes. And you can add also a node selector on the architecture to make sure that they are constrained to those ARM nodes. And should you want to go a bit further, it's possible, thanks to multi-arch container images, to have your application that runs on any node depending on the CPU architecture. So here you have on the top right an example of one of our applications that is doing so. And so on each node, it will pull the correct architecture image. So we discussed a bit the 3 main steps. Is this a good idea? Like how to industrialize? Can it work at scale? And so now a little feedback and key takeaways. So Azure Ampere virtual machines are really performant and cost-effective from our benchmark. And what we want to do next, we can see that they are really interesting to consider for running applications. OpenShift and container technologies are convenient platform abstraction. So thanks to that, multi-arch containers, for instance, we are able to really handle without any issues its kind of new challenges between the application and the IaaS. It was really nice collaborating with these 2 gentlemen between our 3 companies to bring those ideas into the world. So nice collaboration. Then on the ARM CPU architecture, so we think it is quite mature for server use case. So in terms of behavior, we did not have much issue. In terms of open source dependencies, most are already available for this architecture and tested for it. And so the consequence of this point is that most migration efforts are not in the code, but around it. So your CDP, your platform. So that's something you want to consider. Know that technical people would like to have changes in the code, but most probably it's changes around it on your infrastructure and your teams. So it's not necessarily a big project, but it can impact lots of tools and teams in your company. And so as you may saw, it was a bit complex for our use case because we are not starting from scratch with the easiest of application. But if you are already using Java applications, cloud native application in OpenShift, it might be really effortless to try for you. So do not hesitate to do so. And I'll now hand back to Duncan for closure.
And for the question, because you've been the best audience all week, for me anyways, so thank you for that. How many of you running ARM in your companies or your environment or planning to do it? Lots of hands going up. Does the mixed architecture thing attractive or not? Yeah? Really? Okay. Don't tell me that.
No, this is before GA.
Okay. So let me start by thanking these two gentlemen. I don't know how many of you saw the keynote this morning. I know Edward was on stage. This was a great project for me. One of the reasons I enjoy working at Red Hat is the fact that we work with different people, different groups, different customers. And this was one of those where, you know, Microsoft, Red Hat, and Amadeus came together with Amadeus pushing us forward to innovate. It's no secret that we probably wouldn't have gone ahead with this project at all if it wasn't for Amadeus and Microsoft helping us out. It was just going to be too much hassle. So it kind of reinforces the message that you've seen before. I encourage you to go out and try the technology. We definitely see things moving very fast in this space. We think it's a great thing to go do. And again, we're going to take some questions now, but thank you all for staying to the end and not running for the hills as soon as I came back on. So any questions, anyone? There is a mic at the front, but you can just shout as well.
Thanks for that. I'm a big fan of the art. I use architectures. I first tried looking at some architectures on the back. Programming architectures. Actually see what it should be about customer. Going to your story, I'm going to bring chips and pieces. That's critical. How do you actually work in this now, potentially? Given that areas which is very high environment, does that take too long? I mean, flip the story and go through development.
That's something we consider. So for now, it's too early, let's say, in the project to tell. But definitely, if it works and then we have better builds for cheaper money, that's definitely something we can consider. Ouais. So we have several candidates. So we are actually having a shared code base between this product I presented and other products. So the first one we may put in production may not be the one I presented, but we have several candidate applications, and definitely if everything is going forward well, we'll continue doing so.
And if I may add to that, Antoine, as well, we see customers look at heterogeneous operation depending on where they are in their journey and their risk tolerance for the particular workload they're looking at. And so we've seen customers have an extended period of heterogeneous operation, shadow production workloads on ARM, and test and validate for a significant period of time. We've seen customers move very quickly to all in on ARM. And part of the reason is, yes, of course, taking advantage of the underlying economic benefits, but multi-architecture pipelines are not free. And what's great about this is that you have the freedom to do this, and you've got the freedom to select what approach works best for you. Sir?
So we recently seen some tolerations to separate out workloads. Use that anyone. Use that info on like really for the architecture where it's work.
That's kind of an interesting one. So we have been working with upstream as we do, talking about that. And there's a school of thought that currently with the scheduler, they want it to be as efficient as possible and also not have any awareness of the architecture in the system, because you're going to have to pull and do things and they're worried about latency. So what we're working on right now, I'm getting into the whole futures, we're just thinking about it, so please don't kind of make any product decisions based on that.
This last one.
Yeah, famous last words. Thanks, Mo. So we're looking at how we could do what you want, but in a different way. So there's certain things that we could do, like you wouldn't have to set up the taints and tolerations. I don't think we're going to do stuff in the scheduler, but we've got things like the cluster autoscaler. So can we do something with that to do the things that you want to do there that doesn't hit the scheduler? So I think is that, what's fun for me is I need to be really careful. I hope there's no IBM people in here. So I worked on the C system and the power system. So that was very much about, what mainframes have their very good workloads and they're trying to modernize. Whereas with this, there's a lot of opportunity to kind of say this is a brave new world. And we're going to bring Power and Z into this multi-arc. So if you're crazy enough and mad enough, you can run all 4 architectures at once. And what Mo said is really true. For us, I chatted to a customer where he had a decision chart that they went through saying where we're going to run the application. And for me, I don't want OpenShift and what we run on to be a decision point for you. You just go on, you damn well do it where you want to run it. So, but yeah, we're talking about it. We're still thinking about what the best approach is. And as always, we'll work with the community. So you'll see it as soon as we kind of think about it. Because the good thing for me is these two have brains. I've got engineers that have brains for me. So I let them think up the solutions and go on.
Well, I'll add to that as well. I mean, look, we're listening. I mean, we're here to listen. And that's what we do all day. And so asks, please raise them, right? We'll reinforce them and, have one voice here. And really, even one customer can make a big difference for the industry. Sir. That's a very good question. Ampere-based instances are not available in public cloud, in GovCloud, today. Of course, they're available in more than 20 regions across Azure. This is a wide and broadly available product, but not yet on GovCloud. So again, we're listening, right? What we're hearing right now is, there's, I'm not going to give you a timeline, but it's not this year. But it is, on the horizon, absolutely. Yes.
Similar question for the tech tree, bare metal, is that only for Ampere or?
Oh, this is where I get to do my great answer. So we support other platforms. The best way to tell is, so first of all, the Red Hat HCL, go and look there. We have not got a lot of ARM systems on there yet. But the great thing is we've partnered, Philippe's at the back there, give everyone a word with Philippe. We've worked with ARM so that we recognize their system ready certification. So if it's about UEFI boot and things like that being there. So as long as your system's on that, we'll give you support. There's some small limitations, but I guess you'll see it in the news at some point. There's other vendors coming out with products that we'll make sure are in there. So don't be frightened when you look at the list for RHEL and you see it being really small. We've leveraged the fact that ARM have this really good system ready thing to do. Anyone else? Yeah. Well, yeah.
System ready for sure.
Anyone else? Okay. Oh yeah.
Back to Amadeus, your side, is there an execute product that you would accelerate
Tough question. So we have many products, so we cannot say that we'll go all in day one. So we want to try to bring successfully in production one of those products that are critical to the company. And depending on the experience, we'll see where it goes from there.
Okay. Again, thank you all so much. Do you want to say something?
Yeah, no, I was just asking if anybody had an interesting use case they'd like to share, something interesting you're doing with ARM. But if not, certainly please do reach out, and we're here.
I think the next set of presenters will be desperate to get in and get the room. So for my sins, I've got booth duty tonight. So if you're doing the walkthrough from 5 to 7, I'll be around to chat to. I'm sure these gentlemen, well, I think you've got to head off, but these gentlemen will be around, I guess, as well, if you kind of spot them. But definitely buy them a drink, because it's made my life much easier. But thanks. Enjoy the rest of summer.
And thank you, Antoine.